right, hello. Welcome to chapter 11. It's our last chapter for the semester. We're going to be talking about some curve sketching techniques, mins and maxes, and all about derivatives. All right, so let's jump into it. We have the first derivative and graphs for this section. Okay, so we have a function that's a line, right? 2x minus 3, that's a linear function. And we want to determine if it's increasing or decreasing on the interval. So notice these are all the same except for whether it's increasing, decreasing, and the reason, right? So we have to decide which one. So a good thing to do whenever you have one of these types of problems is just start out with a graph and see what it looks like. Put it in the graphing calculator, or if you know what this looks like. So let's see, it has a y-intercept of -3, and then it has a slope of -2. So it should look something like this. All right, so it's going to be a line, and it appears to be decreasing, right? And that's because of this negative slope. And so if we look at the answers, definitely not increasing. So we can get rid of A and C. And again, because I said it was negative slope, that's why it's decreasing. So not because it has a negative intercept, but because it has a negative slope. So B is our answer. So let's look at this one. We have 3 minus the square root of x. So again, let's throw that into a calculator, or if you know what it looks like, we can graph it. So we can start with the square root functions, which looks like this, right? But that negative tells me that it's going to be reflected over the x-axis. And then this +3, it's kind of a plus, that means I'm going to shift it up 3 units. So something like that maybe, where this is 3. All right, so again, based on this picture, based on whatever you see in your graphing calculator, this function is also decreasing, right? Decreasing from 0 to infinity. So we can throw out B and D, and then let's look at the reasons. So because it's a curve that lies mostly below the x-axis, or is it a curve that falls from left to right? So the best answer here is C, because falling left to right is what it means to decrease, or have a decreasing function. So C is our answer here. All right, so another this is a conceptual question. So we have this function here in this box, all right, and we want to know which is the interval in which f is increasing. All right, so this is the graph of f of x. Okay, so we just want to look at when it's increasing from left to right, that means that it's going up, right? So it's decreasing here because from left to right, I'm going downwards. But now notice what happens from B to C. I have an upward trend as I go from B to C. So B to C is definitely in my interval. All right, let's see what else. If we continue on to D, that's also increasing. So perhaps our new interval is from B to D. Okay, so now let's look at for D to E. Again, if we go from left to right, it looks like we're decreasing, right? It's trending downwards. And same if we continue on to F, we're still moving downwards, left to right. Okay, so D through F is not going to be in our interval, but let's look at what happens when we have F to G. If we're chasing it left to right again, I see that we're trending upwards, and that is actually the last interval in which we have that trend. So here are intervals which match A. So now the next question says which intervals is our derivative less than 0, which means when is it negative? Okay, so again, this is our f prime, or sorry, this is our f of x. And so we want to know what f prime is, what the sign of it is. And remember that derivatives tell us all about rates change, right? And graphically, this is our slope. Basically, at each of these little points, we can draw tangent lines which describe the slope at those very localized areas. So when we have a negative derivative, that means that my f is decreasing. So all we need to do is find the intervals in which f is decreasing, and that happens to be the intervals that we did not pick for the previous question, because the previous question we were looking at when it was increasing. So I'm going to highlight those intervals, and you can verify yourself that we're decreasing here, right, from A to B. From C to D, we have a downward trend and on to E. And then from F to G, we're also decreasing. Okay, so this question, the answer is D, right? Okay. Let's do another one. Let's see, so we have f continuous on all real numbers. It has critical numbers at A, B, C, and D, so that's what we see here, right? These critical points. And we need to use the sign chart to determine whether f has a local max, min, or neither. All right, so for the first question, we want to know at x equals a. So right here, is this a max, min, or neither? So using the sign chart, we're given the sign of our derivative. And again, sign of our derivative tells us increasing or decreasing of our function, right? So if I made out this like quick little chart, if my derivative is negative, then that means my function is decreasing. And if my derivative is positive, then my function's increasing. So if we were to add on the f interpretation, when my derivative is positive, f is increasing. And when my derivative is negative, it's decreasing. So graphically, it might look something around a as f is increasing and then it decreases, right? So I have this like local, what is this called? This point right here. This is a local max, right? Okay, so our next point we want to know about B. So I'm going to leave that up. So we know that to the left of B, our function's decreasing, but also to the right of B, our function's decreasing as well. So B does not exist, so we might have some kind of discontinuity or horizontal tangent line, vertical tangent line. But we know that to the left it's decreasing and to the right it's also decreasing, so there's no local max or min, so no local extrema. All right, now looking at C, let me add in the chart. So positive is increasing, negative's decreasing, decreasing, and to the right of C we're increasing. So for C, I have, and I'm just giving an approximate graph, we have something that's decreasing, and then at C it starts to increase. So what is this called right here? This is a local minimum, right? All right, and then for the last one, D, let's fill in this last part after D. My function will be increasing, so graphically I might have a function that is increasing to the left and also increasing to the right. And so let's see, what could we have? Nothing, right? That's not a local max or min. Okay. So here we're kind of going the opposite way, where we're starting with a graph, and we want to know what the sign chart is. So one of the things that I like to do is start off where these critical points are that would form my sign chart. Actually, if you look at the answers, they all have critical numbers of 1, right? We notice they all have these numbers 1, in which we care about the sign of the derivative before and after 1. So if we look at our graph, that corresponds to this point here, right, where we can verify that there's a horizontal tangent line. So a horizontal tangent line corresponds to the derivative equals 0. So again, horizontal tangent line on F means that F prime is equal to 0. So knowing that, we can actually throw out C and D, because this means that it's not defined, and it is defined, right? It's 0. So between A and B, we need to know, is my function increasing or decreasing before 1? So before 1, it looks like we're increasing. So when F is increasing, right, that means my F prime is positive, or is it negative? It will be positive, and so that means plus, 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 right? And so it looks like it's going to be A, but we can verify quickly. To the right of 1, it looks like we're going to decrease. So when F decreases, that means my derivative is negative, or minus, minus, minus. So that's why A is the answer for this one. Okay. So for this one, we want to know what my derivative is, what the partition numbers are, and then the critical numbers. So let's first find the derivative. So F prime, and here's my f of x, my F prime will be equal to the derivative of my F, right? So all of this, and we can break this up if you want, if you're not ready to take them one by one. Hopefully you're getting more comfortable with derivatives by now, but it's okay if not. All right, so we're gonna break them up, and so the derivative of x cubed, that's a power rule, so I'm gonna bring that 3 down, x, and then decrease power by 1, minus the derivative of 3x is just 3, just take that constant, and the derivative of a constant is 0. So our derivative is 3x squared minus 3. All right, so partition numbers for F prime, these are where F prime is equal to 0, or where F prime does not exist or is not defined. So our derivative is always defined, right? It's a polynomial. In fact, it's some kind of parabola, maybe like this. So it's always going to be defined, so never. But our derivative can equal 0, so our derivative 3x squared minus 3 can equal 0 when we can rearrange it a little to find when my x is plus minus 1, right? So negative 1 and 1. And then these critical numbers, these are basically the same numbers as our partition numbers, but they have to be in our domain of F. So our domain of F, or let me put it this way. So domain of F, so F itself is a polynomial, right? It's a cubic function, so maybe something like this. So it's all real numbers, or from negative infinity to infinity. So that's why our critical numbers are the same as our partition numbers. But that may not always be the case, and we'll see an example in the next problem. So let's do the same thing here, right? I'm gonna rewrite F as 9x plus 7 to the minus 1 power. So bringing this quantity upstairs, right? And then just making the power negative. We're allowed to do that, and it'll just make taking the derivative a little easier. So f prime is equal to the derivative of 9x plus 7 to the minus 1 power. We can bring that 9 out and just worry about my x plus 7 to the negative 1. So if we go ahead and take that derivative, we can use the power rule, negative 1, x7. We kind of have a little chain rule in there, the derivative of x plus 7, but that's just 1, so it's an easy one. So I get negative 9 x plus 7 to the minus 2 power, which we can also write this way, and you'll see why in a second. So I'm going to bring that, this quantity back down and then make the power positive. And that's just going to help us in this next part because we want to find where f prime is equal to 0 or f prime is not defined. So in this case, our f is never going to be 0. Right, so f prime will be 0 if my numerator is 0, but since we have a constant up here, it's never going to be 0. But my f prime will not exist if my denominator is 0, right? Because then I'll have a divide by 0 problem. So we want to find where x plus 7 squared is equal to 0. And this occurs at negative 7, yep. Okay, so that's our partition number for f prime. And then now for the critical number, again, it's whatever number we found in B or numbers we found in B, provided that they're in the domain of f. So we have to find the domain of f real quick. So if we look at our original function, notice that I can't have negative 7 because negative 7 for x will give me a 0 in the denominator. So it's all real numbers except for negative 7. And so since negative 7 is not in our domain, we don't have any critical numbers. Okay. So now we want to know where my function's increasing and decreasing, and then we also want horizontal tangent lines and the graph. All right, so again, we want to know where it's increasing, and we can find that out by taking the derivative. So let's take the first derivative, f prime of x. So I'm just going to break it up, derivative of 7, right, just break it up by terms because we have the addition and subtraction rule, minus d dx of x squared. And so now let's take the derivative. That's going to be 0 plus 4 minus, use the power rule, so minus 2x. All right, so 4 minus 2x. And so next you want to find those partition numbers, right? Yeah, partition numbers of f prime. So partition numbers of f prime. And so this is where f prime is equal to 0 or f prime does not exist. And we have a line for our derivative, right? So we know that a line, it would look something like this. It exists everywhere. So this is never, sometimes you will get the case where it has both. There's x values for both, but so far we have not seen one. But just keep in mind that you can have both. But anyway, our derivative can equal 0, and that occurs when x is 2. So that's one of our partition numbers, and we call it a partition number because then we're going to use a sign chart, and that partition will go on it. And we also mark this with 0 because our f prime was 0 for 2. Okay, so now we want to fill out our sign chart. So what you can do is you can plug in numbers to the left and to the right. So just pick test points in each interval to the left and right of our partition number, and then find what the derivative is. You can find the sign even. You don't have to fully compute it if you don't want to. So this is going to be a positive number, or you can go ahead and just say this is 4, right? It's pretty simple. So our sign chart is to the left of 2 is positive, and then if we found f prime of 3, notice I'm plugging it into f prime and looking at the sign. So f prime of 3, 4 minus 2 times 3, so this gives me 4 minus 6, which will lead to a negative number, right? Negative 2. So we can use this and answer both of these questions. So it's increasing, f is increasing when my derivative is positive. So it's increasing from negative infinity to 2. Right, and I suppose we should also look at the domain of f. Should have done that first. So the domain of f, it's a parabola, an opening downward parabola. So the domain of any polynomial, it's going to be all real numbers. But anyway, our function's increasing on this interval, negative infinity to 2, and then we look to see when our derivative is negative, and that will tell me where my function's decreasing. So from 2 to positive infinity. Okay, so I just put what we found just now. And so we're increasing from the left of negative 2 basically, and decreasing to the right. So increasing, decreasing. This is decreasing, increasing, so A is out. B is potentially an answer, right? We're increasing from the left of negative 2 and then decreasing. So maybe B. Same for C. It has that kind of pattern. And then D is decreasing, but then increasing, so no. Okay. And then between B and C, this one has more of a parabola shape or parabolic shape. So that's why B is going to be the answer. I suppose you could even plug in points to determine which one's correct. But you can just do that by the shape. Okay, so now in this problem, we want to do the same thing. Now we have a cubic function, so it's still a polynomial, so our domain is all real numbers, so that's good. So again, let's try to take the derivative first, because we'll know we'll need it. F prime of x, so the derivative of 9 is 0, minus 3, plus 6x minus 3x squared. Just took the derivatives of each individual term. So this is 3 plus 6x minus 3x squared. This is still a polynomial, so looking at my partitions, f of x is 0, and f of x is not defined, and this is nowhere, because it's a polynomial. It's upside down parabola, but we can find out where it's equal to 0 just by some algebra. So I can factor out a 3, 1 plus 2x minus x squared, and so the right hand side factors as x minus 1. Let's factor out a negative 3. And so that will make our x squared positive. X squared minus 2x plus 1. And so this factors as x minus 1, x minus 1. So I have the partition numbers for f prime as x equals 1. Let's create a sign chart as we did in the previous question. So again, I'm going to pick a point to the left of 1, that'll be 0, and to the right maybe 2. and I want to plug that into my f prime of x, sorry. So f prime of 0 is going to be, where did we find our derivative? Right here? All right, so we have 3 plus 6 times 0 minus 3 times 0 squared. And so that gives me a positive number, right? Positive 3. And let's also test f of 2. So 3 plus 6 times 2 minus 3 times 2 squared. So that's going to be 12, 15 minus 12. So that's also going to be positive. Hold on a second. This should be a negative, sorry. That's negative 3 from up here. So that will change our signs just a little bit. So this will be negative. And now we have, let's redo this real quick. So I have 12, minus 3 is positive 9 minus 12, so this will also be negative. All right, so notice that we are not increasing anywhere, so no solution, right? Because my f prime is negative, which means that my f is decreasing pretty much everywhere except 1. Well, it's decreasing, I guess. So yeah, so let's put A, and it's decreasing on my domain. All right. Okay. So I think we already identified that it's a cubic function, so let's throw out B and C, and then from the previous 2 questions, we know that it's decreasing everywhere. So this is increasing, right? And this one's strictly decreasing, so D's our answer. Okay, let's do 2 application problems. So we have the graph of the total profit, P of X in dollars, from the sale of cordless electric screwdrivers to the right. So we want to know a verbal description of this graph. This is our marginal profit function, including discussion of the intercepts, and then we also want to sketch a possible graph of P prime. Okay, so this is our original function, P of X. Okay, so what intervals is the marginal profit positive? All right, so this is our, we want to know where our derivative is positive. So P prime of X is greater than 0. And so this means, where's my P of X increasing, right? So let's see, it's increasing on this stretch, right? If we look left to right, it looks between, this is an X equals 0. And I know it's kind of hard to tell, but this I think is 400. You can just use that magnifier zoom function just to make it bigger, but I believe I got that number to be 0 or 400. So our interval is from 0 to 400. And then we want to know when my derivative or my marginal profit is negative, which means that my profit is decreasing. And so now this is the other side where it's going downwards from left to right. So this is the other half of our interval. 400 is 700. Okay, what points is the marginal profit P prime of X equal to 0? So this means a horizontal tangent line. Okay, and that occurs right here. And those occur when we have mins and maxes sometimes. And so from the previous question, this is 400. Right, I think if you zoom in, I don't know if each of those tick marks. I don't know what the scale is, but 400. Okay, and sketch a possible graph. I should have included our answers, but our answers from A said that it's increasing, or this is for P. So P prime is positive on 0 to 400, and then P prime is negative from 400 to 700, and then P prime is equal to 0 at x equals 400. Okay, so now we're looking at signs, right? Signs, or if it's equal to 0. So let's see, because it equals 0, that means that it's going to touch the x-axis, but actually all of these do, so that's not helpful. Let's look at our first condition, that my derivative is going to be positive from 0 to 400. So this A has no part of the derivative that's positive, so we can toss that out. On the flip side, we know later on that we'll need part of our derivative to be negative, so we can throw out D because this is always positive. So that kind of reduces our choices to B and C. And so the difference is that B has a negative piece, right? I'm looking at sign, not where it's increasing or decreasing now, because these are my graphs of P prime. So it's negative from 0 to 400. But we want it to be positive like it is in C, right? We want it to be above the x-axis. And then after 400, we want it to be below the x-axis right here, this condition. So C is our answer. Okay, so for this question, it approximates the rate of change of bacon, or the price of bacon over a 70-month period. And this graph, it kind of subtly has it here, but it's the graph of the derivative. All right, so we can let's make a sign chart, because it might help us, because we want to talk about B. So we're given B prime, but we want to describe B, our original function. So first we need to look at our partition points. Remember that the partition points are where my derivative is equal to 0 or undefined. Okay, so it looks like our function, our derivative, is defined everywhere. It's a parabola, so we won't have this case. But where is it 0? So that looks to be perhaps, I don't know, 18? Maybe? And we can kind of guess by the numbers they give us in the answer, right? 18 and 34, or 34 plus 18, because it says the next 34 months, so 52, right? That looks like a little more than 50, so maybe 52. It's okay if we're not exact. Okay, and so we need to look at the behavior of the derivative to the left of 18, our first partition. So our derivative is negative to the left. All right, and then to the right, like in between 18 and 52, this piece, notice our derivative is positive, or our graph is positive. And then the last piece I want to look at is after 52. And notice that's negative again. All right, so what does this mean for our B? Well, when my derivative is negative, that means my function B is decreasing. When my derivative is positive, my function is going to be increasing and then decreasing. So let's try to interpret what this means. So the price decreases for the first 18 months to a local maximum. That sounds about right. And then it increases for the next 34 months to a local minimum. Oh, wait, hold on. Is it a local maximum? So if we go from decreasing to increasing, we have this. It's going to be a minimum. I almost didn't catch that. So that's why A is not it. If this was minimum, then that would be the right answer. And I bet this is at 18, x equals 18, and then x equals 52, that next 34 months, we go from increasing to decreasing. So that's going to be a maximum. So that would have made this sentence correct, but it's not. Okay, the price increases for the first 18 months. Well, we know that's not true based on what we found from the sign chart, so no. And no to C as well for that reason. So D is our answer, and we can confirm that based on our how we fixed part, or the choice A. Okay, and then the second part of this question, we want to sketch a possible graph of our B of T. All right, so we have decreases for the first 18 months. We have a local minimum, and then it increases for the next 34 months. This is month 52. And then there's a local max, and then decreases for the remaining 18. So we have something that looks like decreasing, local min, increasing, and then local max, and then decreasing, something like that. Looking at our functions, really only A is it, right? We can throw out B and C because I don't have that kind of cubic form. And then between A and D, notice that, and I have no clue where 18 is. The scale is horrible, but maybe 18's around here. Notice that it's increasing while we want it to be decreasing. So that's why A is our answer. All right, so that concludes our first section of chapter 11, and I'll see you in section 11.2.